In the early hours after the first waves of Allied troops fought their way onto the Normandy beaches on June 6, 1944, one truth became painfully clear to every commander watching the chaos unfold. Capturing a beach was one thing. Sustaining an entire army across it was another. The planners of Operation Overlord understood that the Germans had built their strategy around this very vulnerability. The Atlantic Wall was deadly, but it was only the first layer of the trap. The second was logistical starvation. If the Allies failed to capture a major port quickly, the landings would stall, tanks would run dry, infantry would be undersupplied, and the Wehrmacht would have time to mass for a counterattack. The problem was brutally simple. Every major French port within reach, Cherbourg, Le Havre, Brest, and the Channel harbors, had been transformed into fortified citadels. The Germans had wired harbors with scuttled ships, demolitions, concrete barriers, and interlocking fields of fire. They fully expected the Allies to attempt what had been tried in countless previous amphibious campaigns. Take a port first, then push inland. But Hitler's engineers had closed every avenue. The failure of the 1942 Dieppe raid still echoed like a warning. If the Allies threw men at a defended port, they would bleed out before securing a single usable dock. That left only one option: land on open beaches. But beaches, by their very nature, do not support armies. Sand shifts, tides surge, and surf pounds anything anchored in place. You cannot unload fuel from tankers directly onto a beach. You cannot land heavy artillery or thousands of tons of ammunition without a protected harbor. Without a deepwater port, the Allies were effectively committing to sustain the largest amphibious force in history on the most unstable surface imaginable. This was the paradox of D-Day, a contradiction that Winston Churchill had been worrying about since the First World War. If the Allies captured a port, it would likely be wrecked. And if they did not capture one, they had no way to keep their armies supplied. Logistics officers calculated grimly. Even if the beaches were secured, the buildup required for a successful breakout, millions of tons of fuel, food, artillery shells, spare parts, and troop reinforcements, was far beyond what small landing craft could handle for more than a few days. This was the knife edge on which Overlord balanced. Victory depended not on the first day, but on every day after. And it was into this looming crisis that one audacious idea began to take shape. The idea itself was not entirely new, but now the urgency behind it was unprecedented. As early as the First World War, Churchill had advocated the concept that future amphibious operations might need to bring their own harbor with them, rather than rely on capturing intact ports. During 1942, as invasion planning gathered pace, he issued a characteristically blunt directive. Piers for use on beaches must be capable of floating and working with the tides. That simple demand set British engineers, naval architects, and logistical planners on a path that no other nation had attempted at this scale: the creation of an entirely artificial harbor, one that could be assembled in enemy waters under fire, withstand the violent tides of the English Channel, and operate as a deepwater port long enough to change the course of the campaign. The scale of the challenge defied conventional engineering. A functional harbor requires breakwaters, piers, roadways, anchoring systems, and deepwater access, all elements traditionally measured in millions of tons of fixed concrete. The British had to replicate that functionality using components that could float across the channel and then be sunk, anchored, or deployed precisely where needed. Every piece had to be strong enough to survive storms, yet modular enough to be towed by aging tugboats. Even defining the design parameters was a puzzle. The harbor had to survive heavy seas, offer enough berthing space for large cargo ships, handle thousands of tons of cargo per day, and cope with a tidal range of several meters. To achieve this, the British pursued multiple lines of innovation simultaneously. The Phoenix caissons, enormous, hollow concrete blocks, would become the breakwaters once sunk in place. Bombardon floating breakwaters would extend protection further out, absorbing much of the channel's fury. Whale floating roadways, supported by articulated beetle pontoons, would create flexible bridges from ship to shore, and at their terminus, the Spud pier heads, giant steel platforms that rose and fell with the tide on telescoping legs, would enable continuous unloading no matter the water level. These components were not built in secluded military yards, but in virtually every major shipyard, dockyard, and coastal construction site across Britain. Civilians poured concrete, welded steel, and assembled pontoons without fully knowing what they were creating. The secrecy was so intense that even some senior officers misinterpreted the vast concrete forms as tank traps or anti-submarine barriers. Yet, as the pieces took shape, the magnitude of what Britain was attempting became unmistakable. This was not a temporary pier. It was a logistical weapon, a port designed to win a war of supply. All of it depended on careful timing, tight coordination, and the ability to withstand the Channel's infamous brutality. And as D-Day neared, the pressure mounted. These untested structures would soon face their ultimate trial not in British waters, but under the guns of the Atlantic Wall. By the spring of 1944, the British had transformed stretches of coastline into an immense open-air factory. Phoenix caissons stood along estuaries like silent gray giants, some towering as high as multi-story buildings. Shipyards were crowded with steel frameworks for whale roadways, each segment fitted with ingenious articulated joints, so they could bend with the waves instead of breaking against them. Testing grounds at Garleyston and other remote sites were chosen precisely because the tidal conditions resembled Normandy, violent, unpredictable, and unforgiving. Their prototypes were battered by waves until they either proved themselves or failed spectacularly, helping refine the final designs. Yet engineering was only half the challenge. The other half was logistical and strategic. The Mulberries, as the artificial harbors were code-named, needed to arrive off France after the beaches were secured but before German reinforcements could mount a decisive counterattack. This meant towing hundreds of massive structures across one of the roughest stretches of water in the world, at the exact moment a vast amphibious assault was unfolding. More than 100 tugboats were assigned, many of them elderly vessels never intended to tow thousands of tons of concrete and steel. Every harbor component had to be synchronized. Phoenixes to be scuttled in the correct sequence, bombardons to be anchored in formation, whale roadways to be connected to Spud pier heads as soon as the beachhead stabilized. Maintaining secrecy during this buildup became almost as critical as the construction itself. Workers signed secrecy agreements. Factories produced components whose purpose they could only guess. Security officers monitored unusual inquiries. One of the most famous scares came when a British newspaper crossword suddenly featured the words Utah, Omaha, Juneau, Sword, and Mulberry, all code names for the landings, prompting a brief panic before investigators concluded it was an innocent coincidence. As June approached, pressure intensified. Final sea trials indicated that the harbors could be assembled in a matter of days, provided the weather cooperated. But the Channel is rarely gentle. Even in summer, storms can form rapidly and waves can reach heights that challenge heavy ships, let alone floating bridges. This unpredictability became a looming threat. The entire plan required stable conditions long enough to transport the elements across and anchor them under fire, but time was running out. Once D-Day began, there would be no opportunity to pause or reconsider. The Mulberries had to work on the first attempt. Thus, as the invasion fleet gathered, the artificial harbors, still untested in real combat conditions, lay in quiet readiness along Britain's coast. They were about to face not only German defenses, but the full force of the sea itself. When Operation Overlord finally began on June 6, 1944, the artificial harbor components were still on the British side of the Channel. The decision to delay the landings by 24 hours due to worsening weather had created an immediate problem. Many of the Mulberry sections were already marshaled near departure points. Tug crews waited anxiously as wind and waves hammered the coast. If the weather window slammed shut, not only would D-Day be in jeopardy, the entire concept of supplying the invasion through artificial harbors would be at risk before deployment even began. Yet, on the afternoon and evening of June 6th, the Channel offered a narrow margin of usability, and the signal went out. The harbor components were to move. Over the following days, an extraordinary procession crept across the water. Lines of tugs dragged the immense Phoenix caissons behind them like stone fortresses in tow. Bombardon floats, shaped like hollow steel cruciforms, bobbed uneasily as they were hauled into position. Whale roadways, lashed together in rafts, followed under the careful guidance of naval crews who understood that a single break could send the entire structure adrift. This was not a sleek, modern convoy. It was a slow, vulnerable armada of industrial parts, inching toward a coastline where German artillery still searched for targets. As Allied troops fought inland from Gold, Juno, and Omaha, the first Mulberry components began to arrive off the Normandy beaches. The decision had been made to build 2 full harbors, Mulberry A, at Omaha Beach for the Americans, and Mulberry B, at Arromanches for the British. The work began immediately. Engineers, divers, and naval personnel operated under constant threat. German aircraft still attempted sporadic bombing runs. Artillery shells occasionally found their way toward the anchoring zones. Yet the assembly pressed forward with precision. The first Phoenix caissons were scuttled on June 7th. One by one, these concrete giants descended into the water, settling onto the seabed to form a protective curve against incoming waves. Over the next days, more caissons were sunk in a carefully planned pattern, creating the backbone of each harbor. Bombardon floats were secured further offshore to temper the worst swells. As soon as adequate shelter existed, the Spud pier heads were positioned. Their towering legs drove downward to anchor them firmly, allowing the platforms to rise and fall with the tide. Only then could the whale roadways be attached, flexible steel bridges stretching from pier to shore. Watching them bend and sway in the surf while remaining intact was a testament to the engineers who had insisted the joints must mimic the natural motion of the sea. By around June 14th, both harbors were operational. Large cargo ships could berth, unload trucks, tanks, artillery pieces, and supplies directly onto the floating causeways. The logistical miracle Britain had envisioned was no longer theoretical. It was working, and just in time, because an even greater challenge was gathering on the horizon. What happened next became one of the most severe tests any Allied engineering project would endure during the war. Around June 19th, just days after both Mulberries achieved full operational status, the English Channel unleashed a violent storm, described in contemporary accounts as the worst in decades. Winds rose to gale force, waves climbed to heights that battered everything afloat, and the once steady flow of supplies faltered as the harbors were hammered without pause. For the soldiers on the beaches, the storm was an inconvenience. For the Mulberries, it was an existential threat. Mulberry A, the American harbor at Omaha, was the first to succumb. The Bombardon breakwaters broke apart under repeated impacts, some twisting violently before capsizing. Phoenix caissons shifted on the seabed, their alignment ruined by the relentless pounding. Whale roadways snapped or tore free, their segments drifting inland or out to sea. After several days of punishment, the structure was beyond repair. The Americans made the difficult but unavoidable decision to abandon Mulberry A entirely, reverting to direct beach landings and smaller improvised piers. Though they managed, the loss dramatically increased their logistical burden. Mulberry B at Arromanches faced the same storm, but its positioning, the local coastline, and adjustments made during assembly enabled it to survive. Damage was extensive. Several caissons were breached, some bombardons were destroyed, and roadways needed immediate reinforcement. But unlike its counterpart, the British harbor held. Engineers worked around the clock once the seas calmed, repairing sections as quickly as materials and manpower allowed. The harbor was strengthened, expanded, and reorganized to shoulder the full weight of Allied supply operations. What followed was one of the most extraordinary logistical performances of the Second World War. Despite losing its American twin, Mulberry B, now known as Port Winston, delivered. Over the following months, it moved an immense volume of war material ashore. Millions of tons of food, fuel, ammunition, bridging equipment, and spare parts. Hundreds of thousands of vehicles rolled across its floating roadways. Troops disembarked directly from transports onto the pier heads, marching straight toward the front. At its peak, the harbor handled cargo on a scale comparable to many permanent European ports. By the time the Normandy campaign concluded and major French harbors were finally captured and brought back into use, Mulberry B had enabled the Allied armies to break out, advance across France, and maintain uninterrupted momentum toward Germany. In retrospect, the Mulberries were more than engineering achievements. They were strategic weapons. They neutralized the Atlantic Wall's greatest advantage, confounded German expectations, and ensured that once the Allies gained a foothold in Normandy, they would never be pushed back into the sea. Britain's artificial harbors did not simply support the invasion, they sustained the liberation of Western Europe. That is how the Mulberries won the logistics war after D-Day. If you enjoyed this deep dive into the engineering that helped shape the outcome of the Second World War, consider subscribing for more history told with accuracy, clarity, and respect for the people who lived it. And let me know in the comments, which other overlooked innovations or battles from World War II would you like to see explored next?